So hello class, welcome to lesson 3-2, day 2. Strong mathematicians can use multiplication methods to divide. So you can grab out your notebook, your pencil, put down today's date, the name of the lesson, and let's get started. As you've seen before in this lesson, we got our terms divisor, quotient, dividend, remainder. Hopefully they're starting to sound familiar. You feel more confident of what is the divisor? Could you point to that on a problem? What is the quotient? What is the dividend? What is the remainder? Can you find those things on your problems as you are working? There's our great visual reminder of divisor, quotient, remainder, and dividend in an actual worked out problem for us. Which leads us to today, our second method. We talked about place value methods. We learned how using the area model when we were multiplying. Well, now we're going to use the expanded notation method to use it for division. We know how that works with multiplication, but now we're going to go the other way and use it with division. So same thing works out. Can 6 go into 7? The answer is yes. Well, if I have 7 things and 6 people, they can each get one of them. But instead of writing a 1 here, I would write 100, which would make this 600. When I subtract, I get 138. I look at my 1, 1's less than 6, so I'm good to go. So now I can move to my tens place value, which would mean I change in my 100 for tens, and I would get 13 tens. How many times can 6 go into 13? That would be, said 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, that's too much. So it would be 20, because I'm in the tens place value. 20 times 6 is 120, which leaves me with 18. Is my 1 less than my 6? Yep, so take my 110, turn it into 1s, which will give me 18 ones, and we come up here right there. How many times can 6 go into 18? Well, 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18. That would be it, 6 times 3. 18, and I'm going to subtract to get a remainder of 0. So now I can't leave it like that because it's just a bunch of numbers that are staggered. 738 divided by 6 equals 123. And we'll do the problem again. Said, can 6 go into 3? Nope, it can't go into 3. So if I want to, I can put a 0 here. I don't have to, but I want to make sure I always put my number in the right column. Can 6 go into 39? Yep, so I'm going to start right here. 6 is going to 39. 39 is close to 40, so I'm going to say it's going to be 9 times. So this would be 900. 900 times 4 is 3,600. I'm going to subtract that. So 39 minus 3,600 would be 613. And then in my hundreds, 3 is less than 4. So I move on to my next place value, the 10. So I take my 300s, turn them into 10s, which would give me 31 tens. So 4 can go into 31. Let's see, that would be 5 would be 20, 6 would be 24, 7 would be 28. 4 times 8 is 32. That's too many, so I'm going to go with 70 right here. 70 times 4 is 280. I'm going to subtract and get 36. And the 3 is less than the 4, so I'm good to move on to my 1's place value. So now 36 in the 1's place value. 4 can go into 36. Well, here 9 times 4 was 36. So I'm going to say it's going to be another 9 times. 9 times 4 is 36. 36 minus 36 is 0. So I can't leave my answer like that. I have to put them into a regular standard form number, which would be 979. So you can pause the video right now so you can write down these examples to help you out. Here's a word problem. A party planner has 834 small flowers to make party favors. She puts 3 flowers in each party favor. How many party favors can she make? Looks like I have to make sure I put my capitalization mark. A little grammar lesson right there. Should always start a sentence with a capital letter. So now back to my question. A party planner has 834 small flowers to make party favors. She will put 3 flowers. A party planner has 834 small flowers to make party favors. That was what was making sense for me. She will put 3 flowers in each party favor. How many party favors can she make? I got flowers and favors all going on. So she has 3 per, and she's got 834 flowers. All right. So we're going to start with our 3 can go into 8. I'm going to need a little more room here, so we'll send this down. 3 can go into 8. That would be 2 times. 3 times 2 is 6. This would be 200, which makes 600. When I subtract, I get 234. Notice the 2 is less than the 3 in my hundreds. So now I can move on to my tens place value. So we're turning my 200s in to tens and get 23 tens. Let's see, 3 times 5 is 15, 3 times 6 is 18, 3 times 7 is 21, 3 times 8 is 24. Whoop, that's too many. So I'm going to go with 7, since it's in my tens, it would be 70. 70 times 3 is 210. I'm going to subtract and get 24. In my tens, the 2, which is less than 3, so I can move on to my ones. How many times can 3 go into 24? Well, if 3 times 7 was 21, this is going to be more than that. 3 times 8 is, that's right, look at that. 3 times 8 is 24. It sounded familiar. And it gives me a 0. So how many party favors can she make? I can't leave it like that. I got to write 278. Since this is a word problem, we know what word problems need. Hopefully you aren't labels, labels, labels. How many party favors can she make? 278 party favors. So you can pause the video right now and write down another example of how to use expanded notation as you're solving word problems today. So now it's your turn to try. Box 3, it's now your turn. The expanded notation method. We got 837 divided by 3. And 6,132 divided by 7. You can pause the video, look at your examples, and good luck solving using the expand notation method. And here's a word problem for us. An artist has 956 tiles to use in a design. He plans to arrange the tiles in groups of 4 tiles. How many groups of 4 tiles can he make? So you can pause the video, reread the problem again as part of our strategy, and use the expand notation method to solve this problem. I look forward to seeing your work. As always, if you have any questions, comments, or concerns, feel free to write them down or share them out. If you have any strategies that you use to help you, please make sure you include those as well. And thank you for another great lesson.